Today, we are discussing about the impact of information technology on information services. I am Professor T. Vishwanathan, Director of Indian National Scientific Documentation Center, popularly known as INSTOC. And with me is here William John Martin, Head of Informations Management from Queen's University, Belfast. Welcome to you, John Martin.
Thank you, Professor. It's nice to be here.
I thought we could broadly discuss 4 areas of the impact of information technology on information services. Firstly, we could have a little discussion about what information technology is, and then talk about a little bit on library automation, and move on to design and management of databases, because the databases are very important these days, and finally talk about little about the networks.
Yes.
John, I'd be very happy if you would give a little explanation of what information technology is all about.
Well, I'll try, Professor. First of all, it is not simply about computing. Secondly, I think that before we would even look at the technologies, we would stress the importance of the information and the user, the exploitation, the dissemination, the storage, the retrieval of various kinds of information, pictorial, textual, numeric, all kinds of data. I tend to think of the old Russian word, the troika, the three-legged stool. And one of these 3 legs would be computing and all the computing technologies. The second of the 3 legs would be telecommunications. And the third one I would see is microelectronics. And those 3 technologies have enabled us really to do things which 10 years ago would have been undreamt of. And that to me is the core and the kernel of information technology.
Oh, I fully agree with you, John. I think I would only like to probably add a couple of other fields to this and make it a 5-legged animal.
Why not?
Like the artificial intelligence and the human-machine interface. I presume that you were putting them probably under the computer technology.
I was.
Thing, but I thought they probably merit a little mention. I think in addition to the microelectronics, I also feel perhaps the optical electronics or the optoelectronic is also picking up quite a bit and is going to influence the way we are going to handle information or manage information, as well as the way we are going to provide information services. And what do you feel about the microfilms and microfiches, the old technologies of storing information in microforms? In the context of information technology, do you think that they are being replaced by something new?
Well, I do begin to wonder about cost effectiveness nowadays. I was talking to an Indian colleague, who I suppose had better be nameless, but in a very eminent Indian scientific research institution recently about microforms. And the intention there plainly is to leapfrog this stage and thinking of storage space for journals, instead of putting them into microform, going into CD-ROM, optical storage systems. And if I can just loop back to something you said about optoelectronics, I mean, the whole key to information technology and its impact is the convergence of different technologies, computers and communications, and the advent of optical systems. Talk of optical chips, for example, optical transmissions via fiber optics, optical storage systems, the speed of light being applied to information technology and information systems. It's simply mind-boggling.
Yeah, I just could agree more than what you were saying. But I was just wondering, you see, I mean, apart from the development in optical technology itself, even the development of the microelectronics has been so phenomenal in the 40 years. And I think that's what seemed to have revolutionized the entire thing.
I would agree. I mean, you need all three legs of the stool, or all 5 of the table, or whatever. But in many ways, microelectronics is the core enabler. And going back to the space race, the Americans, terrified by what the Russians had done with Sputnik, and they put all their vast resources into getting someone into space, a man on the moon, as Kennedy said. And as you know better than I mean, much of the bulk of the rocket is involved in the payload, in getting the thing out of Earth's gravitational pull. So everything really had to be miniaturized. And, you know, microelectronics, miniaturization, reliability, disposability, cheapness, higher performance, innovation, everything. And therefore, if you just look at computing technology, telecommunications, embodying all this digital micro technology, where once, you know, in the 1950s, a computer filled a room, now it sits on your desk, now you can hold it in your hand, on your knee. Phenomenal. And I think, yes, microelectronics, very much the key to this.
Yeah, in fact, I'm reminded of an example that I had read, you know, where somebody was comparing the phenomenal growth in the field of microelectronics, and then was trying to apply an analogy to what would happen for automobiles or,
Yes.
you know, aerospace
Yes.
industry. And it's amazing, you know, when he makes that comparison, you know, I mean, the kind of, for example, you mentioned about reliability, I think about 1,000 times increase in reliability, and perhaps 1,000 times reduction in power consumption.
Yes.
You know, energy consumption is
Yes.
extremely important.
Yes.
And also the cheapness.
Oh, yes.
So someone was saying that, you know, if the similar developments had taken place between the 50s and the 90s in automobiles,
Yes.
maybe you could travel from, you know, Belfast to New Delhi, buy an automobile in less than an hour or so.
Yes.
You know, that could have been the kind of change that would have occurred, and each one of us could afford to have 4 or 5 automobiles, probably not costing more than about, in Indian rupees, not more than about 1,000 rupees or so. And whereas, you know, we all know that we spend probably about 200,000 rupees to
Yes.
get an automobile in this country. Very nice. So would you like to say something about the developments that are taken in the field of telecommunications technology?
Yes. I mean, first can I emphasize something that again I find impressive, and it's the relationship between cost and performance, and the fact that in general, certainly if one looks at computing costs, they have plummeted, they have fallen dramatically, all the while performance has soared, with the possible and complicated exception of software, which, as you know, still involves certain bottlenecks, and we're addressing that via software engineering techniques. Yes, telecommunications, I mean, we talk about new technology, and yet until about 10, 15 years ago, telecommunications was old analog voice transmission systems based on the copper pair which we'd had for 100, 150 years. The newness in the telecommunications obviously is first the digital transmission channels, and secondly, as I indicated earlier, the advent of optical systems. Because as you know, the shorter the wavelength, the greater the capacity for carrying information. We always knew that light had incredibly short wavelengths and therefore enormous potential for carrying information. The problem was a means of transmitting it, and the means came along first via the fiber optic cable, the silicon glass cable, and secondly through the use of lasers to boost pulses of light at the speed of light down the laser, optoelectronics. And it would seem that in telecommunications, digitization is here to say optical systems are, as far as one can see, ahead nowadays. In the immediate future, they seem to be the coming system. And when to this you add this great explosion of networking with, you know, satellite communications, extraterrestrial communications, you know, 1.5 seconds up, 1.5 seconds down, you can translate from Bombay to Belfast if you like. It's just mind-boggling, and systems like ISDN, Integrated Services Digital Networks, just wonderful potential.
Yeah, I fully agree with you. I think, you know, I would only like to add, you know, apart from the digitization that has taken place in transmission, I guess, you know, what has led to ISDN is digitization in switching. You know,
of
the
course.
telecom engineers started using computers for their switching,
Of course.
and also the digital signaling, and finally, I suppose, the digital end equipment itself.
Yes.
You see, I mean, we now have to, you know, if you're talking about ISDN, one will
Yes.
have to talk in terms of digital telephone being available
Oh,
at
yes.
home.
Oh, yes.
It's no longer the plain old
Yes.
the analog telephone.
The POTS, plain old telephone service.
That's right. It's no longer that, isn't it?
No, it is not.
Well, I'm really surprised. It's very interesting to know that so much of promises, sort of coming up with fiber optics. But you see, I was reading somewhere, the amount of copper wire that's buried, in this earth is probably 12 times equivalent to the distance between the earth and the sun or something like that.
Yes.
When are we going to replace all this, by fiber optics?
Yes.
I really don't know, because it's something that we have done over a period of about 100 or 150 years.
Yes.
And all that need to be replaced by fiber optics in order to be able to obtain the capacity that fiber optic gives us and effectively use it, particularly in the context of even wideband ISDN, where we probably are talking about voice being, in addition to voice, video being transmitted and so on.
Yes, first of all, in as much as I would understand it, I wouldn't expect that everything would be replaced by fibre. I mean, I would think of optical fibre spines down the centre of a country, major trunk routes, and off those coaxial and indeed copper. And I have seen examples of ISDNs in this fashion, looping from bringing the fibre right down to the local level and then taking copper pairs from there, and it working very well. And of course the Japanese are going for even wider networks, and they're talking about their broadband networks leapfrogging ISDN. They're thinking of even greater. And even in my own part of the world, in the European community, in order to make the community work as one community as much as they can, we've really got a European-wide ISDN now. Optic fibre based, linking main centres, and then after that, twisted pairs.
That's fine. But then the end link perhaps will have the least capacity. So, if you really want wideband at home, I think we need to probably lay fiber optics, I would think. But nevertheless, I think what you're suggesting is the phased approach that one can really take.
I think that's a better way of putting it.
I think,
yes.
I think, well, perhaps there's no other alternative.
No.
Maybe.
And can I interject something here before I forget it? In England, in the English-speaking world, we have certain acronyms. ISDN is known as Integrated Systems Digital Network. But some people call it Integration Subscribers Don't Need. Integration Subscribers Don't Need. And there are others. And one of my great concerns, really, is that the technological capabilities could have far outstripped the demand for their potential. And if you're talking about value-added networks and value-added data services, it seems to me that there is at least some doubt as to whether or not, the business, this kind of business, will be there or will be there in the immediate future to exploit the marvellous technological potential. I don't know what you think.
Oh, yeah, I agree with what you say. But I thought it will be very interesting to see the networking aspect, particularly in the context of the emerging ISDN. How do you see the networks coming up? I mean, there are different types of networks people talk about. Of course, a whole lot of started with the electronic mail network.
Yes.
I suppose the ultimate aim on the networks would be to be able to do document transfer, isn't it? A full document, we should be able to transfer from one end to the other.
Yes.
So how do you view the...
Well, this is happening now. I mean, I tend to think in terms of local area networks within a building or on a site, a campus, and wide area networks, anything beyond that, which includes, the kinds of global networks I have in banking and in airline systems. Obviously, areas where there's lots of money to spare, but it would be impossible to operate sort of an international airline now without access to some kind of wide area network. Even in the academic community, they are networking across, on overlays over national telecoms networks. They are networking CDROMs between cities, between countries. They're even doing that in India. And indeed, full text retrieval services are operating, admittedly at an experimental level in the United Kingdom, but it's working and it is there. And obviously, people prefer full text to references. And this clearly is a coming development of some importance. So Networking, I would take it even at a more general level. I mean, one of the most wonderful advances of the new technology, and via advances in telecommunications and, as you rightly say, microelectronics, is the ability to share, to communicate. The world, to use McLuhan's somewhat old phrase, really is a global village now. 24 hours a day. Just think about what, say, CNN News Network does. It's seen all over the world. The amazing social and cultural implications of that. Now, that's a direct development of networking technology.
Yeah. John, we set ourselves the task of discussing about the impact of information technology on information services.
Yes.
So let's talk about, what has information technology done to the library services?
Right. Well,
and in the field of library itself.
Well, it has revolutionized what we could call library housekeeping activities. The old business of the paper tickets and the book stamping and the loans and the bits of paper in triplicate and quadruplicate. Now your whole issue system, your whole circulation system can be automated. Similarly for processing, for cataloguing books, for storing and retrieving them, you can do all this automatically. And you can buy a turnkey system. And with modules for circulation, for journals, for ordering, for retrieval, you can buy this, and it's just like turning on a switch. It's there. And this, of course, frees up the staff to do many more things which are human resource intensive. The second thing is that information technology has enabled the librarians to get at the information in many different ways. Rather than just looking up a book's title or a book's author, you have seemingly limitless access points to computer catalogues from your office, from your car if you like, from wherever you are. So access, storage, retrieval, management information totally revolutionized library service.
Yeah, but ultimately, I suppose, from your car or from your home or from your office, you should be able to read a book that's available in a particular library, I think. Isn't it? I mean, we haven't probably reached that stage as yet. We are able to probably look at the holdings, whether it's available in the library,
yes,
whether it's been lent out, or whether you can go walk into the library and collect it and so on, make a reservation probably on the,
yes,
on the network itself.
Yes.
John, I've always wondered at one thing. We're talking about CDROMs.
Yes.
I used to visualize the model of an electronic library which is full of CD-ROMs.
Yes.
I always wonder, if someone takes away a CD-ROM to put it on his computer and read a particular book from that CD-ROM, a CD-ROM contains probably about 100 books, let us say.
Yes.
He's not carrying away one book. He's carrying away 100 books with him. Isn't it a very interesting scenario that, while the electronics is going to tremendously help us in the library field, it might also throw up very, very, very interesting new problems?
But of course, it has always been a double-edged sword, advantages and disadvantages, and we must be the masters. We must not be technology-driven. And certainly at the leading edge at the moment, the whole idea of networking CD-ROMs, where they wouldn't actually be taken away, people would access them remotely. And indeed, you can access a CD-ROM catalogue in another city from your CD-ROM catalogue. But yes, there are so many problems about intellectual property, about people accessing, say, an online system and illegally downloading someone else's data, copying it, reproducing it. These are problems. These are real, human, as well as technological problems. But they're nice kind of problems to have because we have gone on to, well, on unimagined lengths we have gone in the last decade thanks to this kind of development.
Oh, yeah. The databases is something that we must say a few words about, I think, because the whole lot of book publishing in some ways is getting replaced by databases in the electronic form. And we're talking about more than 5,000 databases available world over and covering a variety of subjects and, ranging from science, technology to humanities, arts, and religion and whatnot.
Yes.
You talk about anything, you have a database on it, essentially.
Yes.
But I find that database creation is very largely manual intensive even today. You think there will be some automated way of creating databases in the future, like use of optical character recognition systems and optical scanning and things like that?
Oh yes, of course. And then the use of these fourth generation languages, the so-called 4GLs.
Yeah.
And there's such a range of databases. You know, there are the full text ones, there are the tabular ones for essentially quantitative data. There are such a wide range of them. And again, these database management systems, which are designed just to do that, they've got their own programming language to enable you to write, to change, to transform. So this is happening already. But the big bottleneck, as I suggested earlier, is at the level of software. And, I mean, the whole areas of voice and image. I mean, if we could get voice and image processing right, then we really would have reached this somewhat mythical fifth generation that everybody talks about. But databases are here to stay. I mean, the whole, again, back to networking, the whole concept of rather than within one university or one research department, each department having its own information and holding on to it, this is ours. This question of sharing a corporate database accessible by as many people as possible and then accessible outside it by other institutions. Databases are here to stay.
Oh, thanks a lot, John. You know, it's been nice talking to you.
It's been my pleasure, Professor. Thank you.